Good morning, everyone. I'm here in our Engineering 2 atrium in front of the Texas Instruments Innovation Lab, affectionately known as the TI Lab. The TI Lab is great because, quite frankly, it is a workshop for students. Envision it as being your workshop or your garage away from home. It is for our students, engineering, and believe it or not, non-engineering students as well. And it's where you will come to do projects related to your coursework, projects related to whatever you want, any kind of a personal project that you can do here in the Innovation Lab. We have tools, we have some supplies, we have oscilloscopes for you electrical types. We also have 3D printers and laser printers, which we'll get to see firsthand in just a few minutes. But the bottom line is I just want you to know that the TI Lab, it's open Monday through Friday. Right now it's 10 to 6, and soon the hours will be shifting from 10 a.m. till 8 p.m. and we will be sure and let you know. But for now, 10 to 6 is guaranteed. If you need to work later, just check that day and make sure and see if maybe it's open up till 8 p.m. But again, it is your workshop away from home. It is the place where so many amazing and creative projects have been completed. So let's go take a cool look at the TI Lab. Hello again. All right, so again, I'm in the TI Innovation Lab right now, but through the windows here, you can see that is another lab with lots and lots of equipment. That is our Machine Shop Sciences facility. And basically here in the TI Lab, we do have some metalwork equipment. We have 2 metal presses that can be used to cut metal. However, that's it when it comes to metal in the TI Lab. If you need anything like a screwdriver cut in half, a screw cut in half, or if you need anything metal that needs to be milled or drilled or cut, you're going to head into the Machine Shop Sciences facility and ask Jim Assad and his lab techs for help with anything like that. But that doesn't happen here in the lab. Like I said, we have all kinds of equipment. A little quick history about the lab. The lab was created by the current manager, Mr. Don Harper. Don has 35 years of experience and work here at UCF. He created and helped develop this maker space for students. He and I were chatting just the other day, kind of talking about everything that's gone on over the past couple decades really here in the TI Lab. And I asked him, I'm like, hey, what is just the coolest project that you've seen come through, that students have created? And he said, without a blink, he said, limitless solutions. So for those of you that remember that video from orientation when you saw the young man that got the artificial limb that was created by Limitless Solutions, that company started right here in the TI Innovation Lab. So kind of exciting. Don is an amazing person. He has a degree in computer science. He has his own machine shop in his garage, but he also has, again, decades and decades worth of experience with electronics and just helping students with projects. Everyone knows when you start getting involved here and you're doing project work, you'll get to know and love Don just like we all do. But one of the things that I do want you to know, in addition to Don, because he's not here all the time, we have a little army of, just like we have an army of teaching assistants to help us with the 1006 class, we have a little army of lab techs who are vital to the operations here in the lab. And the lab techs are students just like you, they're your peers. However, they've got a lot of experience working here in the lab, using the equipment, and helping students like you. You want to make sure if you come into the lab and you're little like, where do I go, what do I do, where do I get help? Just look for the lab techs. They'll have their name tags on, and just ask them for help. And if they can help you, of course they will. If they don't, they'll find somebody who can help you. Everywhere you look, everywhere there's a heart, a hand to hold on to. Everywhere you look, everywhere there's a...
Hello, my name is Joshua and I'm a mechanical engineering major. I've been working in the TI lab for a little bit over a year.
Hello, my name is Reagan. I'm also a mechanical engineering major, and I have also been working in the lab for a little bit over a year.
And this is our laser cutter that we have here in the lab. If students are interested in using the laser cutter, they can send us, the lab techs, a file to the Innovation Lab email. Students would send in a DXF file, which we would then export as a 2D vector drawing, as you can see on the screen. In this application, we are able to change which lines we are cutting and which lines we are rastering, which gives students a wide variety of different cuts that they can do using our laser cutter.
If students have any questions about samples, they can feel free to reference this list of approved and non-approved materials that we are allowed to cut. We also provide some scrap wood and scrap materials in case they don't have anything they want to cut.
Hi, I'm Mel Allen. My major is electrical engineering. I'm a junior. I've worked in the lab since May 2024, so I think that's a year and a half now. And for the 3D printers, we want you to have your own file that you design yourself on any CAD software. And for the materials, we want ABS, PETG, PLA, or if you have a special material, you can bring in your own, like ASA, PC, TPU, stuff like that. For our files, we want STL or step files. We prefer that. And then if you have a SolidWorks file, we can work with it. We prefer not to though. And then we're able to slice it and upload it for you guys, and we'll help you with all the settings. We do have a limit on how much filament we can use. If you have a part over 100 grams, we will require you to bring in your own filament to print it, but if it's under 100 grams, we can use the lab material. So one of my projects that I'm working on is I bought a tablet from China that doesn't have any cases that you can buy. So I designed and am printing my own case. You can see on the file there, and you can see it printing right now. It's just one of the projects that a lot of people come in and do in the lab.
Hi, I'm Nathan. I'm a mechanical engineering major, and I've been working in this lab for about 3 years, going on 3 years now. One of the big benefits of the lab is we just have a lot of simple tools that you can use for all of your projects. All of the noise that you might be able to hear in the background is everyone working on their statics hands-on homework. And so they're using drills, some of our extra screws, sockets, all that kind of basic stuff. We have that here for whatever project you need, and it's all free to use.
Hi everyone, I'm Alex. I'm one of your lab TAs for this semester. Today we're going to be going over soldering and how to do so. If you can, pull up your web courses right now. We're going to be doing the first attendance quiz. The code will be down below. All right, now that you have it pulled up, we're going to look over some of the stuff that we have. So what you're going to do when you start soldering is you're going to have your pinout board. You're going to have your pins. When you're putting in the pins, they're going to go like this with the metal part exposed, and they're going to go into the board like so. Then you're going to grab your alligator clips, and what you're going to do is you're just going to try and secure it. What I think is best is just kind of have two of your pins, your alligator clips going on opposite sides to it, and then have the last alligator clip holding on to the farthest left pin, and that way the pins will be level when you're putting them in. We're going to turn on our soldering station, and we're going to turn on the thing to help pull away the soldering fumes. This is your soldering pen. Oh, and beforehand, make sure that when you're doing this that you're wearing your safety goggles, because you don't want that stuff in your eyes. Crazy. Here's your soldering pen. When you were holding the soldering pen, you were going to hold it here. You do not want to hold it here. You do not want to hold it here. You want to hold it like at that grip, because otherwise, that way you have the most control, but you're also not burning yourself. When using the soldering pen beforehand, you want to make sure that any excess solder from previous people using it is wiped off. So you're going to go over to your soldering pen station and just wipe off any of the excess there, and that will ensure that you have a cleaner tip. And then before we get into the actual soldering on the thing, when we're looking for the soldering, we want it to make it look like a Hershey's kiss, because that will just be the strongest connection. You want to make sure that it's not too flat. You want to make sure that there's not too much. This is the shape that we're going for. So then we are going to take our solder, and we are going to go on over to one of our pins. what we're going to do is we are going to heat the pin by putting the soldering pin onto the thing. And then we're going to put our solder onto the soldering pen. And then as it melts, what we're going to then do is then pull away the solder and then pull away the pen. If you do it the other way, the solder will be attached still to the thing, and then you'll have to go back in and melt off that soldering. So here we go. We're going to put the soldering pen onto the pin. We're then going to, it's heated up enough, so then we're going to put it onto the solder onto the pin. It'll melt, we pull away the solder, and then we pull away the pen. As we can see, there's a little volcano shape there. And then we will do that again. So pen onto the pin, solder towards the pin. Wait for it to melt, pull away the solder, pull away the pen. So just as a summary, what we're going to need is we're going to need safety goggles. So when you're going to solder, you need safety goggles and closed-toed shoes. When you are holding the soldering pen, you're going to want to hold it by the rubber grip. When we're looking for our shape, we want it to look like a kiss or a volcano. And then we want to make sure the soldering, when we're actually soldering, we solder first by putting the pen on, then the solder on, and then put the solder, take away the solder, and then take away the pen.
Hi, my name is Pete Alferis. I'm the facilities manager here at the College of Engineering and Computer Science. I've been here a long time. I get to work with the freshmen and everyone else, all the engineers in here. I'm sitting next to Citronaut. He's one of my latest projects that I get to work with you as you learn more and more your craft. So obviously you heard about the TI lab, and this is where this Citronaut was created with engineering students. I had a civil engineer, I had a mechanical engineer, I had a computer sciences, and I also had an architect design this amazing thing that we use for athletics. I also have a lot of projects coming down the road, so I want you guys to learn everything that you can, because I have some more stuff that I will need help with. While I'm working in here, this is technically my house, and I would appreciate when you do work on projects, safety is the #1 thing. I don't like to clean up after you. If I have to clean up after you, we got problems. But I know that you will take care of my building because this is your building. So I appreciate if you have any questions or need help and you see me in the atrium or in the TI lab or in the machine shop, please don't hesitate to come and say hello.
Hello, my name's Isaac Joshua. I'm studying Integrated Sciences and Technology. I'm team captain for Squires. We're the group that created this project.
I'm Melanie Allen. I worked on the CAD and the 3D printing for the body and the head. I'm a third-year electrical engineering major.
I'm Andrew Anderson. I'm a mechanical engineer, third year. I did most of the controls work.
My bad.
I'm Ian Ordonez. I'm a computer science major. I worked a lot more on the chains and some minor programming stuff in this project.
So this whole project started a year ago when Mr. Pete, that you heard of, came to us and said, we want a robot to go across the football field. And I went, just a robot? And he went, well, we can do something like Citro. And I went, what about Citro's UFO? So that's how Thunderstruck's Citronaut's UFO was born. You want to go?
Yeah, and from there, they approached me to head up the team for it. So we have a bunch of team members who aren't here right now, like our architect, Parju. He's the one who did the initial proposal designs for the project. Because for the game plan we had for this was create a proposal, send the proposal out, and then from there gather the funds in order to make it happen. And by doing so, that's how this whole thing started. So you're looking at roughly 6 months of work.
More like a year. Took us a while. 6 months of manufacturing.
Hey, good afternoon. How are you today?
Yeah, how are you doing?
Good, thanks. Good. I am Jim Essett. I am the machine shop manager here at UCF Machine Shop. What can I help you with?
I've just got a small project I'm working on. I need to cut some metal, and I was told this is the place I need to go to.
Yeah, we do all that stuff here, absolutely. First off, I want you to know when you come in here, we have a lot of fun. In this room, we get out in the shop, we're a little bit serious. So before we go out in the shop, we have to have on a pair of safety glasses, okay, and make sure there's nothing dangling from your neck, keys hanging from your waist, and if you're wearing shorts with a tie, we gotta make sure your tie's put away. Okay, that's all safety protocol, because we have machines running out there, and I really don't want anybody to get hurt out there. While you're here, let me give you my business card. Every student gets a business card. It shows my cell phone number as well as my email address. So if we have to communicate during the length of your project, then we can go ahead and we can talk to each other, and you know how to get hold of me and how to get hold of yourself. Okay?
Sounds good.
So let's get a pair of safety glasses over here real quick. Okay, I gotta get my glasses on too. So go ahead, you can come right through. The shop is totally accessible. All right, so this is our shop. What in front of you is our work table where all the work that we had in the process sits, and as we delegate it out, it goes. Within the shop itself, we have 2 3-axis, what we call totally enclosed CNC machines, milling machines. The big one over here in the gray, that's our 5-axis enclosed machining center. I'll show you here, we have a couple of manual machines, one on right here in the end and one on the far end. And in the center, and I'll have a better view of this machine in a minute, that's both a manual and CNC machining center open bed that we use for doing different details and what have you for the manufacturer. Right here we have a surface grinder that we use for putting really nice finishes on these materials. Real nice finish on materials. This Haas lathe is a CNC lathe, and over here we have a manual lathe. These machines can turn all kinds of different parts. This is an axle that will be used for a medical robot. Okay. Turn them on the lathe. We do the milling on the ends. Make a hex. Start out as a round piece. Okay. We have 3 CAD/CAM systems set up, which all the machinists utilize out here in the shop. We also have in the office, we have 3 stations set up so that students that want to work inside here, they have the ability to work on it with the SolidWorks. We have a board as we discuss and change things. They can make the changes right then and there using the software. So we're trying to make it more student available. As we build the next room I show you, it's going to be a training room. As we receive an instructor for that, trying to teach more students so they can come out here and they can actually run some of the manual machines. We call this the training room because eventually that's what's going to be used for, is for training. These machines are all CNC. We have 2 of the CNC/manual machining centers, okay, which we have one out in the shop. And then we have 2 lathes that are manual/CNC lathes. They can do everything the big equipment can do, just at a smaller scale. And these are what all the students will learn on. Currently, Owen and Todd are in here setting up a job.
So how much of that drawing needs to be redeveloped before I come in here as a student and ask you guys to help me with the job?
We go through a series of interviews over jobs. Students will bring us their data in or their drawings in, and we'll review that. Based on how the drawing comes to us, it may go back for several changes. It could be because the drawing needs to be updated. It could be because the design needs to be updated. It could be because we can't machine what they want. It could be because we want to maybe change materials and they have to research it. What happens here is we manufacture the stuff. being that I am from industry, I can't cross the engineering line. You're the engineer, okay? So I can give you all kinds of ideas, in which we do. We make it very comfortable. As I mentioned when you came in, we have a great time in there, okay? My job is to make you feel at ease. Let's get through this. You'll understand it. Once that process is done, we will then take your final drawing, your final data, and then we'll produce your parts for you. Okay? So it's a process. You and I will work together as a process until such time that you're happy with it, we can machine it, and then we go ahead and we make it all come together.
Nice.
Thank you guys, I appreciate it. These are the guys that do most of the work out here at this point in time, as I've been developing different things and stuff for the machine shop. So go this way and we can head on out. And as I mentioned earlier, these are the systems we have. I call this my Etch-a-Sketch board. This is where we work with students, fabricating ideas, putting them up on here so they get a concept, keeping in mind that I can't tell them how to design something. That is up to you, okay? If you like the idea, then you take that idea and you can develop into something that's going to work for your project.
So even if I don't have SolidWorks on my personal computer, I'm more than welcome to work on a part here?
That's correct. That's correct. These stations have SolidWorks set up on them. They have actually Mastercam set up on them also, which is the software that we use here in the machine shop.
Awesome.
Okay. Was there any other questions?
I think that just about sums it up.
I appreciate it. We're here 8 to 5. Lunch is from 12 to 1. So typically, I'm usually in the building, but we kind of curtail things for that 1 hour at that point in time. And then we're here to go. Okay. And now if you come in next time and you have a project that you want to start working on, we have a system over here, which we call it's what we call the machine lab software. And you'll come in and you'll have to start swiping in so we can track how long you're here. We know you're in the shop. If there's an emergency, I can download this information in a heartbeat. And if you have to run outside, I have to make sure everybody's accountable. And also, if we're working on your project and you're here with us, we know how long that takes also. Get into once we get to that stage, okay? And we're a little bit away from that, just that you're now just getting started.
All right.
Appreciate it. Nice to see you.
Nice to meet you, Jim.
Nice.
All right. What's up, guys? Welcome to this week's TA Spotlight. My name is Amir. I'm an electrical engineering major in my junior year. So I got about 4 more semesters till I graduate. Go ahead.
Guys, I'm Landon. I'm a junior. I'm an electrical engineering major. So yeah, I got another 4 semesters left to graduate.
Yeah, it's good stuff. We're here at Foxtail in the Breezeway. If you guys don't know where that is, it's right next to the library, closer to the reflection pond.
Yeah.
Honestly, awesome. Better than Starbucks in my opinion. On Mondays, they have $3 iced coffee or cold brew, so that's pretty fire.
Yeah.
Good place to study, good place to hang out. You want to tell me what you're drinking?
I managed to grab a hot chai latte with a shot of pumpkin spice in it because I was feeling festive.
There you go.
So it's good, man. It's just the right amount of spice. I love it.
Fire. Some things I like to do for fun. If I'm not on campus, which I usually am, I'll usually be at home. I live with like my best friend, so we'll be doing something random. He's got me into like hunting, into fishing, a whole bunch of cool stuff, and then I like to play games here and there, and yeah, hang out with my family, with my friends, my girlfriend, and things like that.
Yeah, if I'm not at school, I'm usually at work as a soccer referee, which is a job in and of itself.
Yeah.
But if I'm not working, sometimes I'll sit down, I'll play Clash Royale. I'm like 9,400 trophies right now.
Dang.
I've had that account for like 9 years.
That's actually valid.
Dude, I'm struggling to get out of the Valkyrie arena. Oh my god.
Yeah, no.
It sucks.
It's literally terrible.
If any of y'all play Mega Knight, I'm coming for you.
But I play Mega Knight, so hopefully he's not talking to me.
Throwing this drink at you.
But yeah, So we talk about some advice now, advice for students.
Yeah.
For all my young electrical engineers out there that are questioning their major, I was in that position once before. Stick through it. It gets a lot more fun the later you go. Once you get into LC1, LC2, those linear circuit classes, actually start doing circuit analysis, you really start to apply your major. It's honestly, it feels rewarding when they give you some crazy circuit and you're able to find, I don't know, the sinusoidal or the phasor voltage or whatever you need to find. So stick through it. Obviously, the benefits financially are fire, but it's a fun major the further you go.
Yeah. If I had to give some advice to the incoming students, be prepared to change your major. Not a whole lot of people know this, but I was actually a computer engineer before I transferred over. I took one coding class and went, wow, this is not what I want to do for the rest of my life.
True.
And so I switched over to electrical. I don't regret that at all. And I've been having a lot of fun. But just be prepared to change your major at any point. You may take a class that, you just don't like, and it will suck, and you're going to realize, like, wow, I'm going to have to do this not only for the rest of my college career, but into the professional world. Do I want to do that as a full-fledged adult? And you may have to, do some reflection at the reflection pond.
Which we're not far from, right outside the door.
Dude.
But, yeah. Anything else you want to tell them?
Nah, have fun, man. College is fun. Don't get too caught up in work. I see a lot of students who get way too caught up in their work and stuff. That was me freshman year. Mm-hmm. I barely hung out with any friends or anything like that. But
enjoy it. Enjoy it while you still can, while you still have the time to. And this class gets a lot more fun. So stick it out. Not only this semester, but next semester. You really, really start to feel like you're an engineer the further along we go. So it'll be a lot of fun, guys.
Yeah. Stay hydrated too.
It's hot out here, but thank you.
See y'all.
Bye.
Okay, so what do we show them? What do you mean just wing it? Ugh. Oh, hi. Hey guys, we're IEEE, an organization for and by electrical and computer engineers at UCF. And this is our president, but we'll hear more from him later. Okay, so now you know who we are, but what do? Okay, so we do 4 different types of events. Workshops to help you learn new skills, social to help you make new friends, service to give back to the community, and ProDev to help you develop professionally. Oh, and I almost forgot, projects! We have a ton of cool projects at IEEE that anyone is allowed to join, including, but not limited to, the SEC Robot and Micro Mouse, our autonomous robotics projects, and Guitar Hero, our audio effect and guitar pedal design project. Joining projects is a great way to get hands-on experience and receive mentorship from many of your peers. Okay, so that's a bit about us. Now a word from our president. No, the actual president.
Hi, my name is Matthias Gillen, and I am the president of IEEE at UCF.
Look at this guy. He's so happy. He's happy because of IEEE at UCF, and he's going to tell you 3 reasons why you should join. Starting now.
The chance to make an impact by learning through our projects and workshops. Professional development opportunities that help you build a strong reputation. Fun socials that help expand your network and connect you with peers. We'd love to have you join our community and grow with us.
It's true. We'd love to have you. To join the community, just scan the QR codes below.
Hey guys, welcome back to Go for Launch with the GTAs. Sorry I missed y'all last week. I was up in Michigan for a wedding. It was super fun, but definitely missed being here. Also, before y'all say anything, I know I was wearing an Oscar Piastri shirt a few weeks back. My support of him has not changed. I do like McLaren a little bit more, but Red Bull just had a really cool hoodie.
Big fan.
And it's cold in this building. So with that, we'll go on ahead and kick off your announcements before you exit out of here with your graded survey. So, Ellie, you want to kick us off?
Yeah, absolutely. So you guys are going to have a couple of assignments coming up this week. On Sunday, you're going to have your Chapter 3 of SimNet due. So you guys should be hopefully familiar with SimNet by now. Everything should be synced up with your web courses and you should see those grades rolling in. Then you're also going to have that weekly schedule assignment that you guys should have covered in your lab. And you'll see that Excel template and you guys can fill that out or be creative with it. Then you'll have your technical communications assignment, and that's your first group assignment, so make sure you're getting in contact with your group so you can get everything filled out. And if you guys have not noticed this already, if you download the web course or Canvas app, there's going to be that little tab at the bottom that's your to-do list, and it lays out everything. Oh, it's absolutely beautiful, and when you see that sleeping panda when everything's done, it's even better.
That normally doesn't happen until the end of the semester.
No, it's not done until exams are done, but that's okay. So if you guys,
that's what we strive for.
That's what we strive for, the sleeping panda. But if you've not seen that to-do list, make sure you download that app so you can get that to-do list and it organizes everything super well for you so you can see everything that you have to do for the week.
Yeah, it's also super handy because as someone who avidly uses the Canvas calendar, a lot of my professors will put Zoom invites on the calendar, but then they don't show up on under the to-do list, which makes it so much easier because I have one class that, I kid you not, has like 6 Zoom calls set for Monday, but I don't know why. So I'm always like, why do I have 6 assignments due on Monday? It's not. I check my to-do list and it's only 1 or 2. Mm-hmm. So it's a great tool to help ease your stress out.
Absolutely.
So those are the assignments that we've got for you guys. For next week's lab, you guys are going to be meeting your TAs in the atrium. We're going to do a mixed mode kind of lab where half of you guys will be in the atrium brainstorming your ideas for this launcher project, which we're going to get into in a moment. While the other half practices soldering in the TI lab, so you get your feet in the door, and then you'll trade off. You do have to do both activities to get full credit for attendance.
Yes.
So there will be a brainstorming activity that you'll come up with a launcher design that you have to turn in via a piece of paper to your TA. That piece of paper will be provided to you guys. And you have to complete your soldering activity to get credit. So you can't just show up to one half, you have to show up to the entire lab, and you have to meet in the atrium. There'll be signs posted on the 260 door just in case you forget.
Yep.
But
we'll
for
have
soldering,
3 tables reserved in the atrium for you guys as well, so make sure you're keeping a lookout for your TA. They'll be by those 3 tables, and that's where you guys will meet, start, and end your lab.
Cool.
Bye, Doug.
So for soldering, what do they need to know about attire?
So in the TI lab, especially specifically for soldering, as you heard from Alex a little bit ago, you guys are going to need your safety goggles, which will be provided in the lab. For anyone with longer hair, you're going to want to make sure you have a way to tie it back in some way, and that you're going to want some closed-toed shoes.
That goes for everybody. Everyone should have closed-toed shoes.
Yes, because everyone should be soldering. So make sure you have all of those things, and then if you have glasses, you get excused from the goggles, as Ryan here is demonstrating.
Even though I still like to wear my safety goggles, I've done one too many corporate trainings where they're like, make sure you wear your plastic safety goggles because the glass ones will shatter and get glass into your eye, or like the plastic ones will catch knife blades before they enter your eye. So I've been a little traumatized by those. But it's personal preference, but you do have to wear some form of eye protection.
Absolutely.
Contacts don't count.
No, they do not.
Glasses or safety goggles.
Yep, which we will have for you guys.
Yep. One other thing to note with the soldering activity, you do need to review your group number. So if you go into web courses in your lab section and click on the people tab, there'll be groups, and that's where you can find your group number. That's going to be imperative for figuring out where you're going to start and where you're going to end for next week's activities. So make sure you're aware of that and take that stress off of your TA. They will still know your group, but it's more efficient if you know your group number, so that way we can get you guys moving through the lab a lot more efficiently.
Absolutely.
So.
And now for what exactly you will be brainstorming, we wanted to give you guys a little bit of a preview as to what this robot project is going to look like. So we have our little friend down here. This is going to be the robot you are working with, the TIRSLK kit. It has been slightly modified from what the original was. But this is what it's going to be looking like for you guys. This little blue part up here, that's going to be your gyroscope. That's going to be something you're going to be working with. And then you're going to have a line sensor down here. So those are the 2 things you're going to be really focusing on. And then you might be wondering what all of this Velcro is for. Do you want to tell them what it's about?
Yeah, so may I? So on this robot, it will follow a path using the line following underneath. So it'll go along, and then it has to hit a wall. And that wall is our duck pond. Your goal is to launch as many ducks as possible into the pond. and you're scored based off of that number of ducks that make it in. We'll go into more detail in a few weeks, but this way you get the basic idea. These little Velcro pads, this is what your launcher attaches to. You can make them out of 3D printed parts, you can make them out of Legos, you can make them out of cardboard. Any sturdy object will work. They just have to be able to launch that duck. So you'll have a robot on the table that you can use, as well as a duck, to start getting ideas of sizes. We'll provide rulers, those sorts of things, as well as the dimensions for this height here. So you're able to figure out what you're looking for and where your arm needs to be, so you can kind of start brainstorming a solution. The goal is to be as creative as you'd like to be. We've seen launchers that have been like this high up off of the robot.
Tower.
Yeah. Students have just put a pile of ducks on top and dumped as many as they can. They come in little forms.
Servos, people have used servos
Yep.
to electronically motorize the arm to turn on its own. So many different ways to do it.
Yep, but the biggest challenge of this project, these little switches here, these are bump switches. In order for the robot to reach the wall and know that it needs to turn around, it has to still hit these bump switches. So you have to engineer something that allows the robot to hit these bump switches and still launch your robot, or launch your ducks. So that's your challenge for next week while you're soldering, is to start brainstorming. We want to give you a bare bones idea of the project so you're kind of freed and can do whatever you would like, and then we'll start introducing some of those restrictions and constraints down the line. That's how engineering naturally develops. I've been in the design studio a couple times, so it's always a free-form thinking, and then we start narrowing it down as we go. So it's a true practice of what it looks like in the true engineering field.
Absolutely.
Yep. Anything else on the project?
I think that's going to wrap it up for our little project overview.
Cool. So you'll see these in the atrium next week.
Yep.
But what I do want to talk about is a reminder from last week's lecture. Academic integrity is extremely important. We cannot tolerate any form of academic dishonesty or cheating that includes sharing quiz codes or answers. This is supposed to be a respectful course for everybody. We're trying to help you guys learn. You are aware now that quizzes are not always going to look the same as an exit quiz. We did those first few weeks. This week's was even different.
Yep.
So please just keep that in mind. Be respectful of everybody and their learning and where they're at. This course is designed to introduce everybody to the major, so that way they understand what they're getting into. This is a life commitment for what career you want to be in. Granted, you can always go back and change your mind. That's possible. But we want to help prevent that so you know what you want to do and you're passionate about it. Therefore, it makes the work a lot easier. So, it might not be interesting at times, but the goal is that it's interesting to somebody every week. So, as always, if there's any feedback, you can let Ella and I know.
Please do.
Yeah.
Reach out. You can put it in the comments wherever you guys have any feedback. We will take it and be receptive to it. And that way we can make this the best course that it could possibly be for you guys. And we can show you what you want to see and what would help you best.
Yep, exactly. And so with that, today we heard about the TI lab. You learned about the machine shop. You learned how to solder. Make sure you're still completing those module activities for next week. It might be a little bit of a repetition, but we really want to reinforce the safety that comes with soldering.
Yep.
You heard from some different clubs. You got to meet Amir and Landon.
Shout out. They were my students 2 years ago, so fun to see them as TAs now.
Yep.
Could be you.
Could be. And then you got to hear a little bit of an introduction of the robot project. So with that, we're going to close out and we have our exit quiz. Please let us know, I mean via the quiz, so please take the quiz and tell us whether or not this is going to be your first time soldering. And with that, we hope you have a great weekend and we'll see you next week.